As we look around the environment, we see that there are rocks that bear a resemblance to the sedimentary and igneous rocks that we've already learnt about, but they don't quite look the same. And we find them in areas that we can see have been exposed to heat, pressure, and time. I'll give you an example. Here's an environment here where we have a whole heap of layers of rocks that tell us a story. There's mudstone, which tells us that at some point this land was covered with water that's washed a lot of mud over the area. Then there's limestone, which tells us that the land was covered with water that had a lot of shellfish and shell-like creatures in it, and that their shells have dissolved into the water, and as the water's evaporated away, the dissolved shells have actually precipitated again, turned back into solid, and recrystallized on the bottom to form limestone. Then we have a layer of sand over this environment, and sand tells us that something here, either wind or water, has washed sand across this limestone until it was thick enough to form a large layer. So on top of this we have more pressure from more layers above. So there's more layers up here that are pressing down to turn this mud and limestone and sandstone into hard rock. Now, if you dig a little further, we find that some of this rock has actually changed. This stuff in a straight line down here has actually changed into a different type of rock. So the sandstone has become quartzite. This limestone here has turned into marble, and mudstone has become slate. Now, the fact that these align straight up with their previous layers but have a definite column along here leads us to think, okay, what has actually made all of these rocks into something new but left these ones here unchanged? Look a little further and you see this. A volcanic tube extruding basalt, which was of course magma, up through the ground, which would have then cooked the rock that was beside it. And all of these different rocks appearing alongside a volcanic tube like this tells us that heat is the likely reason why these rocks have changed types. When we look at mudstone and slate, you can see they're composed of the same materials, but slate is a lot harder, but still has those layers that it had when it was mudstone. Marble still is made out of the same stuff as limestone, but again, it's actually a lot harder, and because it's in its cooked form, it looks slightly different. Same with quartzite. You can see that it too is made out of the same things as sandstone, but again, it's a lot harder and looks slightly different. Another incident that people noticed was that these types of really hard versions of rock, like the quartzite and the marble and the slate, could be found not where you had volcanic tubes coming through or exposed to high heat, but where there was obvious evidence of what we call folding. Now, this sort of folding indicates that a huge amount of pressure has actually been put on these rocks in this direction like this, and that pressure has forced them to fold like that. And where you have that folding, you actually have these rocks being made from previous other rocks like mudstone, limestone, sandstone, or other types of sedimentary or igneous rocks. So wherever you see this folding too, we find that instead of having a sedimentary or an igneous rock, we'll have what we call a metamorphic rock, which is obviously used to be one type of rock, but it has been changed and hardened into another version of itself, which is much harder and much stronger than it was before. So we find these metamorphic rocks appear in two different places, places that either are exposed to intense heat or places that are exposed to intense pressure for a long time. So metamorphic rocks, they form under intense heat and pressure over time, and they are made from pre-existing rocks, not sediments and not lava or magma. Let's have a look at some. Here we've got some sedimentary rocks. All of these are types of mudstone, so they can be siltstone, mudstone, claystone, all ones that are made out of fine sediments like mud. Okay, different colors of course, because as we know, mudstone is simply very, very, very fine sediments that have been cemented together in stone, and their colors depend on what type of sediments they are made from. Now these same mudstones, if you cook them or put them under pressure, they change into new types of stone. Here we've got slate. Slate is cooked and pressurized mudstones. So here is a slate quarry here. This is slate. Because it can be cut into fine layers, is often used for roof tiles. Here's some tiles here from England. Now here are some other examples down here, and these are quite obvious. You can actually see the folding lines to show what sort of pressure these rocks have been under. Notice how they've been folded up. That's because they've been put under so much pressure that these rocks have actually started to bend and fold. They've been exposed to an awful lot of pressure. You imagine how much pressure it takes to bend a rock. And because of that, this previous mudstone has metamorphosized into a new type of extra hard rock called slate. Now, slate itself can be pressurized even more. If you take slate, and here are two pictures of slate here, and put it under even more heat and pressure, you'll actually turn it into what we call schist, which is slate which has been put under more pressure until it becomes an even harder version of the previous rock. Now notice with all of these you can actually see these distinct lines and layers in here. We call this foliation. That's because a lot of the minerals, any of the minerals that are similar, will actually tend to line up as they're put under heat and pressure and form these little layers called foliation. Now take schist and heat it up again or put it under even more pressure, and you end up with gneiss. So we've gone from mudstone to slate to schist to gneiss, which is this rock here foliated even more. See how you have the distinct lines of dark and light? That's because the crystals and the atoms in there actually reorganize themselves as they're put under that intense heat and pressure, so that the ones that are quite similar tend to line up and move together and cement together even harder and form an even harder version of themselves, and in this case we call it gneiss. So mudstone to slate to schist to gneiss. Now, I said before that sedimentary rocks weren't the only ones that end up turning into metamorphic rocks. You can actually have igneous rocks doing this too. Here is basalt. It's made from lava flows. If you put it under intense heat and pressure, but not to the point where it melts, it will actually form this. This is amphibolite. And basalt, under intense heat and pressure, turns into amphibolite. Again, you have that foliation, that distinct layers of dark and light, but very tiny, tiny layers where the crystals have reorganized. And if you look at it quite closely, you can see it has a lot of the similar colors that it used to have in basalt. But the minerals have basically reorganized themselves into something a lot harder and a lot stronger, and quite different than what it was before. Next we have limestone. Now limestone, as we've already learnt, is the remains of decomposed shells from marine organisms, and once it's dissolved it then precipitates again as the water evaporates away and leaves layers and layers of recrystallized shells essentially, which we call limestone. Well, if you take limestone and you put it under intense heat and pressure, it turns into marble. That's right. Marble is cooked and pressurized limestone. So that actually used to be the dissolved shells of marine organisms there. And as we know, we have lots and lots of uses for marble. But just like the dissolved shells of marine organisms and your teeth, they're all made out of calcium carbonate. Because it will dissolve in acids, it means that marble too is also quite vulnerable to acids. So if you put anything like a mild acid, even vinegar, on a marble bench, it can actually react with the marble and start dissolving it, and you'll see bubbles of carbon dioxide being released as the marble dissolves. So this is one way we can tell if something is marble or limestone. Put a little acid on it and it will start to bubble up as the carbonate in calcium carbonate turns into carbon dioxide gas. Now lastly, I have sandstone, because this is a beautiful stone that we have around the place, a lot of it in Australia. And this is what sandstone looks like. Well, if you put sandstone under heat and pressure, it turns into quartzite, because sand is made out of quartz crystals. We have cooked sandstone becoming quartzite. There again, you've got that foliation, those different light bands and dark bands through this. This one here shows extreme, not only foliation, but folding. You can see how much pressure this sandstone must have been under to bend it like that. That sort of heat and pressure causes a change to happen in sandstone. Quartzite is a lot harder and a lot stronger than sandstone. And that's the biggest thing when you look at these metamorphic rocks. They might look similar to their previous ones, but they're a lot harder and a lot stronger than the previous forms. And of course, when you get to this stage, if you put them under any more heat and pressure, it will get to a point where they will once again melt and turn back into the lava and magma that they came from. And that's how we go a full cycle around the different types of rocks.